So, shh, just waiting. All right, in a moment, what I'm going to do is give you your first little strip of paper. These strips of paper I have taken from the periodic table, and what I've done is I've cut the periodic table horizontally. And I want you guys to fill in the electron configuration and see if you can notice some patterns and trends when we're talking about the periodic table. It has been organized in a very specific manner for a reason. Now, when it comes to how to do your electron configurations, I'll do two of these as an example, just to get you guys going, and then I'll give you out your sheets. So, let's first start with lithium. So with lithium, or whatever strip I give you, we're going to be looking at the periodic table, and we're going to be grabbing the smaller of the two numbers, because the smaller of the two numbers tells me atomic number. So I'm just being mindful that with lithium, I'm working with the number 3. So that's my atomic number. If lithium has the atomic number of 3, how many electrons does it have? Jokes. Oh, so 3. All right. Now, when we are talking about electron configuration, remember the first shell gets 2. So we're going to put our first 2 electrons here. 1, 2.
Do they have to be next to each other?
No, you can put them further apart. I just like to do them in pairs just because it's easier for me to count them. Now that I've filled up that shell, I'm going to the next shell. How many electrons do I still have?
1.
Just the 1. And then I'm writing my electron configuration is 2 and then 1. All right, Grace is giving me that face that she needs another example. That's okay. All right. The next example that I will do you want me to do a big atom or a small atom?
Big.
Big? All right, I'll do potassium.
Oh.
Whoa.
No.
No? Sodium? Sodium? Okay. So, sodium, in this case, I look for the atomic number. It is 11. So how many electrons am I working with? 11. How many go in my first shell? 2. 1, 2. All right, how many electrons do I have left over now? 9. 11 minus 2. How many am I going to put in that second shell, though? What's the max it can hold? 8. So I'm going to put 8 in my second shell. 1, 2, 3, 4, 5, 6, 7, 8. How many electrons do I still have?
1.
1.
2, 8, 1. I don't get it.
And then when I go write my electron configuration, I have 2, 8, and then 1.
So can we only have 8?
Huh?
Wait, what?
Yeah. So when it comes...
So the first shell, it can only go 2, right?
Yeah. So first shell can only have a max of 2.
And then the second one can have a max of 8.
Yeah.
And then the last one...
Third shell.
What if it has more than 3 shells in it?
Then you move on to the next one. So you see how I had 2 electrons in my first shell? I can't put any more in there, so I move up to the second shell. I put 8 in that shell. Can't put any more. Move up to the third shell.
Then can I put 8 in that one?
You go up to 8 with that third shell. And then the fourth shell, you can put up to 2.
What if there's more than 4?
If there's more than 2 in the fourth shell?
No, it's more than 4 shells.
If there's more than 4 shells, you're taking level 3 chemistry.
Okay. But then why is there more sugar cookies on the blue one?
I can only explain that if you take level 3 chemistry.
Oh, okay, that's very cool.
You're just going to have to trust me that this is the basic foundation. Okay? All right. Cool. Let me pass out your strips. You guys are trying to figure out... let me go back to the screen. Here we go. All right. So, I'm going to give you guys your first strip of paper. I want you to practice electron configurations. Glue it into your book once you have it done. Compare it with someone that's sitting next to you that has a different strip of paper, and I want you to see what the pattern is. Okay?
I don't really get it, but yeah, I'm trying.
All right, everybody. Let's move on to some observations that we've made, hopefully. Headphones out of ears.
Thank you.
All right? Just waiting for the chatter at the back stuff. Everybody? Lovelies. Time for the notes. All right. So, you're going to go in while I talk. I'm just going to show you guys some things first.
Yeah.
All right. Right now, I am looking at the periodic table, and I'm looking at it based off of the columns. So when I say the columns, I'm talking about going down like this. If I'm looking at that first group here, my hydrogen, my lithium, my sodium, and my potassium, what do we notice about them?
They're in a line.
They're in a line? Yes. What do we notice about the numbers?
One. They end with one.
They all end in 1. All right, let's move over to the next group.
They all end in 2.
They all end in 2.
3, 4, 5, 6, 7.
And then this is a little bit complicated at the end. These guys are 8. This one's 2. But that's the maximum that
Circle can have.
the shell can have. Yep. So, if I was trying to state a pattern on my periodic table, if I go down, we refer to the going down on our periodic table as our group. And the group number can tell us how many electrons there are in the outer shell.
Oh, yes, 1.
But it doesn't say.
So this one here is 1, that one's 2. It gets a little bit complicated over here, because in this case you're doing 10 minus the number. So 13 minus 10, 3, 4, 5, 6, 7, 8. So a nice little hint when we're looking at our periodic table.
Electrons in other cells.
All right, so when I go down my groups, the groups are really important because they tell me the trend when it comes to how many electrons are in that outer shell. All right, next trend we are looking at, which is a little bit harder to see. I'll zoom out so that way you guys can see it. I'll do that. All right, that's our first row. This is our second row. Here's our third row. And then that's our last row. What do we notice as the pattern? The shells get bigger, and it's really specific. So in my first row that I have in my periodic table, if I was looking at the hydrogen and the helium, they only have the 1 shell. When I go to my next row, these guys here, lithium all the way to neon, they have 2 shells. Once I fill up my second shell, I then go and start the next line of the periodic table, which is my sodium. And these guys have 3 shells. When I fill up that guy, I start my next one, and these are now my 4 shells. This only works up to calcium. If you want to know what happens after calcium, you got to take level 3 chemistry. Oh, sorry. All right, so when we are going this way, we are talking about our row. You might also hear it being called period. And this tells me the number of shells. So, hydrogen, helium, 1, second, 2, 3, and 4. So these are really useful hints for you guys if you're trying to quickly figure out electron configuration. Because, for example, if I was looking at boron here, I could automatically assume, where's my boron? There you are. 2 shells, because it's got the second row. And in that outer shell, I should have 3 electrons because it's in group 13.
What does it say at the right?
Rho is the number of electron shells. E minus equals electron.
Is it 1 E or 2?
1E, because I made a mistake. That's a scribble. There we go. Alright. You guys should have this written down somewhere on your periodic table or somewhere in your notes, hopefully, so that way you remember this key bit of information.
Do I have to write the numbers on it?
You can. And then I'll move on to some more information.
What's your favorite thing?
Right, can I move it? Right, let's put how many times have I had to say to put away the phones? My computer froze. What's going on? Come on. What is going on? There we go. Oh, should be. All right. Ready for the next bit? Okay. All right, moving on.
You want to write these?
Yep, more notes. Sorry. Then we'll move on. Okay. So, something to remember about atoms is that in order for them to be stable, they need to have a full outer shell.
What? For atoms. For atoms. Atoms need
So for atoms to be stable, they need to have a full shell. All right, just going to move out. I'll put that in the notes. That way you guys, if you still listen to that. Okay, looking at these guys, which one has full shells?
all of them. All of them.
All of them?
The first one, you choose. Starting from the third one. The right.
Is the third row full?
No, the fourth. Yeah.
How many
The
electrons?
last one. The last one.
The last one. So you see how all these guys here, they don't have a full shell. Because remember, the numbers that we're looking for is that 2, 8, 8, 2.
Only the last one.
So only the last one are full and stable. So we call group number 8 the noble gases. And those guys there are stable because they have a full shell. So if they're stable, they have a full shell, they are unreactive. So what does unreactive mean?
Not a full shell. I don't know.
It just means that it won't react. It doesn't tend to be involved in chemical reactions because it's already stable.
Wait, what's that 8 thingy? That's noble what?
Noble gases. So these have full shells. They tend to be stable.
Full cells, stable,
And unreactive.
full.
So they don't take part in chemical reactions. So that means that everything else on the periodic table is going to need to do some type of reaction in order to be stable. And there are two choices in what they do. All right, can I move it?
Yeah.
Move it? All right, so we have two choices. The first choice is that atoms can share electrons. Forming a covalent bond. So sharing is the key word. So the example I will use is water, because we drink lots of water and we talked about it today. You will be able to have the periodic table. Yeah. All right, so let me draw two atoms for you guys. If I do oxygen, the atomic number is 6 in that guy, right? So I have 6 protons. I believe it has the atomic mass of 12. So it should have 6 neutrons in the nucleus. That's my nucleus. And then if I have 6 electrons, I have 2 in my first shell, and then how many in my second shell?
4. So there's not a full one.
Not a full one. Yeah?
I don't know if I'm wrong, but it's the oxygen is the atomic number is 8.
8?
Yeah.
Oh, my bad. I probably made a mistake. Good catch. I have a periodic table in front of me. I should have gotten that. 8. So that should be 8 as well. And that would be 8 because it should be 16 then, right? Yeah. Okay. So I'm going to put 2 more electrons down there. We good?
Yeah.
Now, what else is in water? Do you guys know? H2O. So what does the H mean? Hydrogen. And what does the 2 mean?
2.
I have 2 of them. If we look at the periodic table, how many electrons does hydrogen currently have? 1. How many does it need to be stable? 2. So what happens is that it shares electrons with
H2O.
with the oxygen.
Huh? What's the blue circle?
So the blue is my hydrogen.
Oh.
And the atomic number is 1. So do you see how, by doing that covalent bond, hydrogen now has 2 electrons?
Yeah.
So it's sharing it.
But how does that work?
They overlap their electron shells and they share the electron. So hydrogen sharing its one with the oxygen sharing one of its with the hydrogen. And the same thing happens with the, I'm not drawing this very well, with the other overlapping circle. Sorry, it's not a very good circle.
What's that one that you just drew?
That's another hydrogen.
Oh. It's sharing.
They're sharing. So the overlapping circles is showing that sharing.
So why is it 2? Because it's 2.
So I need 2 hydrogen atoms.
Okay, yeah.
So that way oxygen now goes from 6 in the outer shell to 8. 1, 2, 3, 4, 5, 6, 7, 8.
How do you make water?
You light hydrogen gas and oxygen gas.
Oh, can we
You
do
did that with the pop test.
Can we do that so we can make some water?
We did it the other day.
When? We did it
In like the first week.
Why would it come out?
You may have missed it.
Oh, yeah. Oh. Can we make water, please?
All right. So when we're thinking about chemical formulas, that's H2O. So if I'm translating this across, how many oxygens do I have? One oxygen atom. How many hydrogens do I have?
Two.
Two. How many total atoms do I have?
3.
Time do we end?
Is that it?
25. That's for the first option, then there's another option.
Wait, option for what?
How to get the right number of electrons. So this is option 1.
What's the second option?
Put option 2 on the next page. Yep, I will scan it as well. All right, ready for the next one?
Yes.
All right. Option number 2 is that atoms can give and take electrons. And they're going to form ions that have ionic bonds.
We want to hold on.
So if you guys remember when we were talking about element, compound, and mixture, the difference between the compound and the mixture is that the compound has chemical bonds. The mixture does not. So in this case, we have the ionic bond. In the first example, we had the covalent bond. Oh, I need a different color. All right. So let's look at some examples.
Can I go to the bathroom and go to the Christmas?
Yep. All right, let's look at beryllium. So beryllium on my periodic table has the atomic number 4. It has the atomic mass of 9, so I have 5 neutrons here in my nucleus.
What does that mean? They're more dots.
Yeah, so this is beryllium, Be. It has 2 electrons in its outer shell, and then how many are going to be in its outside shell?
2.
2 again.
So that's not a full one.
It's not a full one. Now in this case, we're thinking about gaining or losing electrons.
Oh my god.
So we want to get a full shell. I have 2 options. I can lose 2 electrons and drop down a shell, or I can gain 6 electrons and fill my shell. Which one do you think is easier?
Remove.
Removing them. But it can't do that by itself. It needs to have a buddy to do that, doesn't it?
Yeah.
So let's say, for example, we have fluorine. Actually, fluorine? Yeah, let's do fluorine. All right, so fluorine has the atomic number of 9. So 9 protons. Its atomic mass is 19, so 10 neutrons. So how many electrons in my first shell? 2. How many electrons in my second shell?
8.
We sure? 7.
Oh, 2. And then take away 2. But then that's 9.
So how many electrons does it need to fill its shell?
1.
1. How many does it need to lose to go down a shell?
1.
7. Which one do you think is easier?
1.
Gaining 1. So do you see how, in this case, beryllium is going to give away one of its electrons to the fluorine? So how many electrons does beryllium now have? 3. Because I've given one away.
So then do we gotta give another one?
We got to give another one away. So I need another fluorine atom. So there's my nucleus with my 2, and then my 1, 2, 3, 4, 5, 6, 7. So it's going to give, oh, I did not draw that very well. Now I have my electrons going funny places. Sorry about that. So we see beryllium's giving away 2 electrons, right?
Yeah. And then they made 2 for them.
Huh? And then each one of the fluorines are getting 1, 2.
Yeah.
So you always have to have a pair.
So how do you pair it? How do you know when you pair it?
Well, because I look at the electron numbers and I look at how many electrons does it have, and I decide does it need to gain or lose. So then I have B, E, F, 2
Oh, damn.
as my formula.
Then how about taking away 2 from beryllium and adding it to oxygen?
So if I was doing, that's a great question. If I was doing that with oxygen, then oxygen would get both of those electrons because it needs 2 electrons. So it'd just be B, E, O. We'll do some more practice on this, don't worry. I just want to give you guys some ideas. Nah, because I have to wait like 3 months. All right, so things we have to remember when we're looking at our formulas, whenever we have these little subscripts behind, it is then counting what is in front. So if I have 3BeF2, we got to translate things very carefully. So this 2 behind only refers to the fluorine. Are we okay so far? No. So what this tells me is that when I look at this formula, I have 1 beryllium atom from over here, and 1 fluoride, or sorry, 2 fluorides, 1, 2.
Yeah.
So that's what the subscript is. I'll tell you what the 3 is for. All right, the other number here is known as my coefficient.
Is that how many atoms?
How many molecules there are, how many compounds there are. So that 3 applies to everybody behind. In that formula. Yeah, so if I was to do that math, that'd be 3 beryllium. Now remember, we start with 2 fluorines, so 2 times 3, 6 fluorines. Total, how many atoms do I have?
9.
9. That's how the atomic math works.
Can we get numeracy criticism?
Not in this standard, but there will be other standards that you do. This is not a whole lot of math. right. Keep going. Are you guys ready to give this a go?
Yeah.
All right. No? We'll do some practice. Don't worry. Okay. So let me just pause the recording so we can play our game of Last Man Standing. I will explain it. We'll do a couple practice rounds and then you guys will stand. I will explain. You guys are very impatient. And my mouse is not working, which is a little irritating. Okay. What has happened? Okay, I have no idea what happened here. What are you doing? Okay. Oh my goodness. Why are you working today? Okay. Alright. You guys show me board. Oh, show me board. You can show me. Alright, I'm going to write a chemical formula on the board. I'm going to give you guys some markers. No, wait. I don't think I got it like that. Alright, Sam.
That's what we did. Just did.
I'll let you guys have some practice and we'll play the game. Alright. Whiteboard markers and erasers. No, those don't work.
Oh, she's back.
Alright. Oh, Grace. You need a whiteboard. Alright, so what I'm going to do is I'm going to write a formula on the board. I'm going to ask you a question and I want you to write the number. The number. So I'm going to be like H2. Oh, I don't like the green. Get a different color. Alright. Like I will write H2O and I will ask you how many atoms are there?
3.
And then you write 3 on your board. And then you show it to me.
That's not a 3.
Right.
How do you know the last man's name?
Well, I want you guys to practice for the board for the game. That way you guys aren't upset. Alright. Next one. How many atoms?
I don't know.
Calcium and oxygen. Aluminium chloride. How many atoms?
2.
Four. There's 1 aluminium, and then that 3 applies to the chlorine. 1, 2, 3. 4.
There is. Oh, okay.
Okay, good. Alright.
Aluminium 4.
Alright. How many oxygens?
3.
How many oxygens?
2.
How many total atoms?
3.
No. it. Okay. What if? I wrote a 3 in front of here, and I want you to tell me how many options there are.
2.
How many options?
3.
How many options?
6.
6.
3 times 2. Oh, dad. Oh, dad.
How many carbons? How many carbons?
1.
3. 1 times 3. How many total?
7.
9, no, 8.
6.
8.
Plus what?
8. 9.
You want me to go through that? Alright. So, I have 3 times 1. That's my carbon. I have 2 from my oxygens. Times 3. That's 6.
Okay.
That's where I'm getting 9.
Okay.
Alright?
Okay.
You guys want to do some more practice? Or are you ready to play the game?
Play the game.
I'll give you 2 more practices and then we'll play the game.
Yep.
Alright? We have 5 minutes left. You guys want to play the game, I'm guessing?
Yep.
Save the for activity time?
Yeah.
What do you guys?
How many minutes?
Okay.
Wasn't the whole session though?
75 minutes is the whole time.
We got 5.
Alright,
Mitchell, she's the part of them.
Alright, how many magnesium?
4.
How many chlorides?
8.
What?
4 times 2.
How many total? Alright, ready? Shall we go? Ready to play the last time standing? Yeah, person standing, I should say. Okay, so here's how last person standing works. You get 2 lives in this game. So the first life, you're on your chair, and you hold up your board. If you're right, you're gonna keep standing. If you're wrong, sit down. Sorry, you stand. You go from standing to standing here. That's your first life gone. And then your second life is if you get it wrong, you get to sit down.
Can we just stand up?
And the last person standing wins the game.
Yo, listen.
Alright? So you're standing up here first.
Can I just stand?
Well, then your boss is a life already. You're already down a life. If you want to start on the board, you just negative 1 life already.
It's hard.
This is not like you guys on the board. Okay. Alright.
Ready?
Alright, how many atoms? Write it on your board, don't say.
Atoms.
How many atoms? Right, one on your board, hurry up.
2.
Number.
Say no way I'm wrong. No way I'm wrong.
That's all. 3, you guys. Or that's it, you stand.
No way.
The answer was 2. Alright.
You get it wrong.
How many chlorides?
How many chlorides?
The chlorines. Oh. Do you see your board? Do you see your boards? The answer is 2. Looks like everyone got 2. Alright. Here's the rundown. Now, how many total atoms?
2.
How many total atoms? Stop looking at each other's boards.
I'm not. What did you get?
6 was the right answer. Oh, yeah,
I wasn't even thinking.
Alright. How many chlorines?
4. Don't yell it out. 3 out it out. Oh, she's now. How many?
No, I'm just
See your boards? You see your boards?
Where's your board?
The answer is 4. Because there's 2 here times 2. 4. Yeah. If you've been knocked out of the game, you're welcome to stand up in the front with me and you can help me identify the letter knocked out.
Yeah, and then add
No, you want to put it down?
Well, why?
Guys, just famous.
All is 2 as
Alright, how many total atoms? Total atoms.
What'd you do?
It's 3. You guys can stay standing. Alright. How many oxygen atoms? Oxygen.
My hat looks crooked.
Michael sits down. Luciana sits down. The answer is 5. I'm gonna try to knock you guys out before the end of the hearing. Right. Oh, it's harder. Okay.
That's it.
Wait, I'm not done yet.
7, 6.
Alright. How many oxygen atoms? How many oxygen? Hurry up. Right number. The answer is 12.
Yay!
Alright. How many aluminium? Quickly.
That's 8.
How many total atoms? 20! You guys are getting too good at this.
So I'm not.
Okay, you know what? I'm gonna be mean. You're gonna have to get it right now. Alright? Ha ha! Ha 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 ha! Ha ha ha! How many total atoms? 5!
Why am I staying on the table?
Alright. There are 6 atoms there. Everyone moves to
Shame, we're gonna find!
on the table. Nice. You got 5 right there. This one's 6, 2 sodium, 1 carbon. I'll give you guys some more practice next week. Alright, go ahead. Bring up. Let me get the whiteboard markers back.
That's not mine.
Cheeseburger will tell me if I don't get them. Whiteboard markers, trophy boards. Whiteboard markers in my bag, please. What do we have now?
All right.
Get you those pairs out, hurry. Now that you guys know what you're doing, here we can play Steve Pick. No, I'm trying to get here because fast. You did fast. Try this. See that? Yeah. You're right.
Oh, thank you. we're looking at adaptations, and I'm gonna give you guys time to start your posters. Yeah, Helena, how are you?
Okay, we like the product set.
Maybe. Yeah.
So make sure you count out the whiteboard around with the one with much about
If you want this in the box, grab it. If not, you're welcome to use the box anytime. We're going to be looking at adaptations today, so can you guys get your books out? I promise I won't get anything too laborious for manga. I'll make manga today. Do you guys like the word unscrambling?
I do.
Okay, you'll enjoy it. I have some words to unscramble.
Oh!
Yeah, I'm done.
That's not what I'm saying.
There you go.
Oh, do you have the whiteboard?
Yep. There you go. Oh, are these? Now you're working.
Okay, random question of the day that you will tell me today is what is your favorite organism? I was going to say animal, but let's be original. This is biology. Okay, guys, so what's your favorite organism? That's tomorrow's question now. Thank you. What's the lead on? When someone says their favorite organism, what do you have a better connection? That's a good question.
Oh, shoot.